Hello, Algebra 1. In these notes, we're going to learn about solving equations with variables on both sides of the equal sign. So as always, be sure to pause the video if you need to, if and when, to catch up with the notes. So the first thing we're going to start with is a little fill in the blank. So steps for solving equations. So if you have a lonely variable, that means a variable that does not have a number multiplying in front of it, put a 1 there. So just to remind yourself that there is an understood 1. Then what you're going to do is you're going to simplify. So you're going to look if there's any parentheses and anything you need to distribute, a multiplier across those parentheses, you'll do that. Then you're going to look and see if you have any terms you can combine. So you're going to combine like terms. Then for step number 3, you're going to move the variables to one side of the equal sign, and then you will move your numbers, sometimes we call those constants, to the other side. Now, a couple more definitions that we want to get down is sometimes when you're solving, you will get an equation where all the variables will subtract out for you, and you'll have a statement like a number equals that same number. This is an identity equation. That means any value that you plug in for x will make the equation true. So here's the definition of an identity equation. So this is an equation that is true no matter what value is plugged in for x, or for whatever the variable is, the value. And if you solve that all the way down, simplifying each side and moving numbers over as much as you can, you will get 0 equals 0. And then we call that an identity equation, and that means that there are infinitely many solutions. We can also, when solving, get a strange situation where our variables will subtract out and we'll just be left with a statement that is not true. And this is a no solution equation. So this is an equation where no value makes the equation true. So when solving, you will get a false statement like 0 equals 8, which it doesn't. And that is not true, and that indicates that that is, we can also call that false, and that indicates that there is no solution. All right, let's look at some of these. So we have 7 minus 8x equals 4x. So we don't have any lonely variables to put a 1. We don't have any distributing or combining like terms on the separate sides of the equal sign. So we can start moving variables to one side of the equal sign and numbers to the other. So let's start by adding the 8x over to the right side of the equal sign. You can just pick which side you'd like to move the variables to. I like to stay positive, so I moved the 8 over, so it'd be a plus 8. Now I'm going to move my negative 17, so I just add 17. 24 equals 12x. 12 is multiplying by the x, so I'm going to undo that by dividing. And now when I write my final solution, rather than writing 2 equals x, I can just swap the sides of the equal sign and say x equals 2. All right, look at number 2 with me. Notice that we do have some parentheses, so let's start by distributing. So 10 times 2x is 20x, 10 times 2 is 20, bring down my minus x, 2 times 8x is 16x minus 16. Now look at the left side of the equal sign. Notice that we can simplify a little. We can combine those like x terms. So 20 minus 1 is 19x plus 20 equals 16x minus 16. There's no more simplifying to do on each side of the equal sign. So now we can move variables to one side and numbers to the other. So I'm going to subtract my 16x over to the left side, and I'll just rewrite what I have. Now I'm going to move my numbers, my 20, over to the right side, so I have to undo it. I subtract it. Negative 16 minus 20 more is negative 36. The last thing, to get x by itself, it's being multiplied by 3, so I'm going to divide. So my final answer is that x equals -12. Let's continue and let me show you some examples of an identity equation, and then which is always a true statement, and a no solution equation, which will never be true. So again, let's start by distributing. So I'll distribute my 2, and then I am going to write in a 1 and distribute that -1. So notice that will give me a -3x and then plus 6. So now I'm going to combine like terms on the right side of the equal sign. So that'll be 2x plus 6. Now if I think about that, that can't be true because 2x and 2x are the same thing. So I can't subtract 4 on the left, add 6 on the right, and have it be equal. But let's continue solving. So let's move our variables over and notice that the x's subtract out and I get -4 equals 6. Well, no, it doesn't. So I'm going to go ahead and add that 4 over and just follow this problem all the way through. So that gives me the statement that 0 equals 10. That is a false statement. That is not true. So that indicates that there is no solution to this equation. There's no number that we can plug in for x and do the math that we had at the beginning that will make the left side equal the right side. Now I bet you can guess what number 4 is. That's going to be an identity equation. So let's start by distributing our 2x plus 6 equals, I'm going to write in that 1 so that I'm going to distribute the -1 and get -3x plus 6. Now I'm going to simplify on the right side of the equation. So I'll subtract those and get 2x plus 6. Yes, I mean that is true, but I'm going to continue solving. So I'm going to move my x's over and they eliminate. And I get 6 equals 6. Definitely a true statement, but I'm going to continue just moving that number over so that I get 0 equals 0. It always does, and that's a true statement. So that indicates that this is an identity equation. The next 3 problems are independent practice problems. So I would like for you to pause the video, work the problems, then come back and restart the video and check your answers. All right, welcome back to number 5. So the answer that you should have got is x equals 3. If you did not, look at my steps. So you should have combined your x's. I moved my 5x over to the left side, got 4x minus 7 equals 5. Then I added my 7 and divided by 4. Now for number 6, how's that for fast math? So your answer should be x equals 2. If you did not get that, then take a look at my steps. Notice I distributed my 3 in the first step and got 12 plus 3x on the right side. Then I moved my x's over to the left side and got 11x, then added the 10 equals 22, and finally divided by 2. Now let's talk through the last one. Crazy Carnival charges $10 entry fee and $1.30 per ride. Wonderland Carnival charges no entry fee but $2.30 per ride. How many rides must you ride for the 2 carnivals to cost the same? So to write an equation, we have to first locate what's our unknown. So we need to know how many rides. So let's let that equal our variable. So x in our equation will stand for the number of rides. Notice we're looking for how many rides when the carnivals cost the same. When you see the word same in math, that means equal. So we're going to write an equation where we have an expression for Crazy Carnival, what it charges, and set it equal to Wonderland Carnival. So for Crazy Carnival, I have a $10 entry fee plus $1.30 per ride. So I'm going to be multiplying. So that'll be on the left side of our equal sign. Now on the right side will be an expression in math for what Wonderland charges. So there's no just entry fee, no $10, but it's $2.30 for each ride. So we'll be multiplying. I've set them equal, and now I can solve for x, which is the number of rides, which tells me how many rides a person can ride and still have it be equal. So we're going to subtract our $1.30x and get 1x equals 10, and that means that if you ride 10 rides, you will be paying the same amount for Crazy Carnival and Wonderland Carnival. And that concludes the notes for solving an equation with variables on both sides of the equal sign.